Good morning, friends. It gives me immense pleasure to welcome you all for today's webinar on how to be a better data, how to do a better data analysis. Today's session is being taken by Mr. Brad Theissen. He is the Director of Client Services, Arbitrus. He has been with Arbitrus since 2007. Brad first started learning about computer-assisted audits back in 1993 when he joined ACL. Back when ACL was a company of just 12 people. During his time at ACL, he was a frequent speaker at many audit conferences and chapter meetings. Brad has a degree in finance and worked in financial leading prior to joining ACL. With this, I'm going to give the I'm going to give the control to Mr. Brad.
Well, thanks very much for that kind introduction, and thank you everybody for joining us today. Happy Friday morning to you all. You're closer to the weekend than I am. I certainly appreciate the invitation to come and speak with you today, and hopefully you get some value from that. As the topic says, how to do better data analysis. There are certainly many barriers to why audit teams are not able to accomplish better data analysis, and certainly I'm not going to cover the scope of that today. But as it relates to technology, what I wanted to hope you get out of today's session is that you're going to see some ideas on things that you may want to try. These may be things that have not even occurred to you before that you may want to try. Maybe things that you have thought of but didn't really see an easy way to accomplish them. Or they could even be things that you thought of, you are doing now, but you see a much simpler way to accomplish those. So hopefully you're going to sort of get a number of different things, some ideas, a number of those levels today. By the way, that slide on the screen, that's not Vancouver. Okay. Now the format for today is I'm going to show you some slides, and then where it relates to software, I'm going to jump in and show you that. Before I did that, I was going to cover off a couple of very common questions that I receive prior to proceeding. One of those is, how do you pronounce our company's name? A lot of people are puzzled by that. Here is the phonetic pronunciation, Arbutus. We hear a number of variations on that, from Arbutus and everything else. So anyway, that is the phonetic pronunciation for Arbutus. Now, the second question that we get is, what is an Arbutus? Unfortunately, we're in silent mode, so I won't survey you group, see which one you know. But the answer to what is an Arbutus is, it's a tree that is native to this part of northwestern U.S. and Canada. That is an Arbutus tree that you see on the screen. It's quite a unique tree, and that's why we felt it was a good name for our company. That and the domain name is available. Anyway, what are you going to see today? The scenarios I was going to sort of utilize to sort of touch on some of these ideas and examples. First of all, one was payment analysis, another one vendor analysis, and then we'll jump a little bit into what deployment administration of audit tests can look like, some ideas around that, and then if we have time, touch on a little bit of setting up and validating data. Now, before I do that, or as sort of a preface to that, I was going to give a quick explanation on Damerol-Levenstein. And so most people who I ask this about will not be familiar with this. Some people are, but more people probably are not familiar with this term, Damerol-Levenstein. This is an algorithm that was developed a number of years ago that has just really more commonly found a real good place in the area of fuzzy analysis. The basic explanation of how Demerol-Levenshtein works, again, is an algorithm that allows you to compare two different values, two different strings, and then what it determines is how many changes need to happen from one string to make it the same as the other string. And then it assigns you that number. So in the first example here on this slide, you'll see 123 Main Street, where the street is the full street extension. And we compare that to 123 Main Street, where it's just ST. That is a Levenshtein difference of 4, meaning the REET at the end of street are the only differences. If you added those, they'd be the same. This next example is 3, 4, 5, 6, 7 compared to 3, 4, 5, 7, 6. Data transposition errors, just we would consider that, or data transpositions, whether it's intentional or not, represent a value of 1 with the Levenshtein, and so on. So you can see the next example, Rob and Robert, difference of 3. Gary and Mary, difference of 1. So that is the general premise. I just wanted to explain that quickly before jumping in, and this relates to some of the examples that we do when we get into some of our analysis. The first test I was going to walk you through is in the payments area. I'm going to grab my highlighter here and just to maybe I want to show you is doing an analysis. We're going to try and look for payments where there's the same date, same vendor, same amount. The key piece is here, you want to look for invoice numbers that are not the same, but are similar in appearance. So when I do our analysis, look at the fields there that I'm highlighting. You'll see 96/244 is actually was matched up with 96244. And the next value, 113933, was matched up with I-13. So you can see why they were matched up. The focus is, in this example, is on trying to easily identify duplicates where there might be a data entry error, or if you're even doing something like OCR, bringing data in, whatever that might be. This gives you a way to look for similar looking values, commonly on various kind of reference data, in this case invoice number. So let me switch over quickly to Analyzer. Oh, how do I turn that off? There we go. So now we are looking at, this is about just under a million record input payments file with just a few fields. And I'm going to use this for a few examples. So this is Analyzer. I need to make another change here. There we go. If I go to the Analyze menu and go to Duplicates, you'll see on the right in the middle there are a few different values there. There's ability to check for same, check for different, and then near and similar. Near and similar both utilize that Levenshtein, Demerol-Levenshtein that I explained a few minutes ago. I'm not going to get into a lot of detail today. The key thing is I just want to give you some sense that a lot of these tests are quite sophisticated but can be done in a relatively simple way. And let me show you how we accomplish that result set. So here we again have a million records. I can say I want to check for the same amount, same date, same amount, same date, and let's say same vendor and invoice number. Now if I choose similar, which is what we want to use to identify similar looking invoice numbers, how our software works is the last field selected is where you're going to apply the similar to. And I'll just give this a quick name here. Call this check 1. And I'm going to apply this fuzzy test on a million records. So I'm just going to process that and hopefully give me a result set. And so just a few seconds. And here's what we're looking for. If I bring across that invoice number to this one. Here is those matches. We went through those 1 million records. Again, this is a live demo, and showed you that we found 4 instances where there were payments and invoice numbers that are similar in appearance. So that's one example. As you saw there, they're just choosing off a menu. You choose duplicates, you choose similar, you select your fields, click OK, and that was not sample data, or it was sample data, but it was not small data. It was quite a large file, and able to not wait very long and get some results in. Next example would be another test where you are going to say, I want to check for same date, vendor, say same invoice number, and let's say the digits are transposed. So if I get my highlighter out here again, here again in the middle is how these ones were matched up. You can see the bottom one, the last 2 digits were transposed. That is obviously not a material difference, but everything else is the same. But here you can see in this top example here, the first 2 digits, 78 and 87, are transposed and everything else is the same. So switching back here to Analyzer, if I go back to the screen here, and let's bring up that data source again. Let's switch back to my arrow. I'm just going to reopen up that file again, and we can do the same test again. So back to our duplicates command. In this case, I'm going to say same date, same invoice number, and same vendor. And let's see now, again, I want to check for transposed digits on the amount field. So if I now go back to there, I'm going to put in value of 1 here. And as you mentioned, that transposition errors are classified as a 1, so that's why we want to do a test there on 1. I'll give us a value here of check 2, and run this command. So again, going through these 1 million records and finding a couple of results. When we do a duplicates test that engages fuzzy capabilities, we actually give you the results side by side, so it does allow you a more easy way to do further filtering if that's what you want to do. But the key thing in this case is that we looked for these, and so you can see same date, same invoice number, same vendor number with only transposed digits on a relatively significant amount that may have not got caught with whatever control thresholds you might have had on that, and this gives you a very simple way to test that. So you get a couple of examples here of using our similar tests, one on a character field, one on a numeric field, to identify some potential duplicates, and the simplicity with which that's accomplished. Some of these things probably could be done, other technologies, but one of the barriers for some of these tests being done, at least by a broader group of users, is the simplicity with which they're done. And sometimes another barrier is on file sizes. And that's kind of why I'm using at least a 1 million record file. Clearly this could be much larger. You saw the results were accomplished in just a few seconds. This can be applied on very, very large data sets, which again takes away one of the barriers that are commonly bumped into when you're trying to do fuzzy analysis, which can be quite a demand of resources and need to allow hours, if not days, of due processing on large data sets. Now I'm just going to reopen up that file again. Go back to my slides. Let's move on to the next example here. Now this particular test, we are looking for payments to same vendors where there might be an outlier as far as the format of that vendor's invoice number. Each vendor, you're getting invoices from all different organizations, but invoices for each vendor typically are going to adhere to the same format. So in this particular case, you can see here the one I have on the slide. There is this vendor, and invoice number is off by 1 digit. If I get my highlighter up one more time, you can see here only one. And how that was identified was creating a computed field that showed you the format of that. And let me go back now to the software and show you how straightforward that is to set up. Okay. Let's check something here. So to create a computed field, I go to Add Columns. I can click on Expression. And on the bottom right is a list of over 100 plus functions. So I want to focus in on the one that's called Format. And essentially what the Format function does is any field that you put in there, in this case I'll put in invoice number. Anytime it sees a digit, it puts in a 9. Every time it sees a letter, it puts in an X, whether uppercase or lowercase, and all the other values it sees it leaves as is. So if I just call this a invoice format, click on OK. I'll now add that to my screen. So here now is the format. If I was curious what all the formats were from all our vendors, I could even run a classify on that. And I can go through and you can see here, here's all the different formats for different vendors. You can see some of these vendors have a letter as part of their invoice number. Now the test we want to do is go to our command here called classify. And I'm going to, in this case, create a simple expression that I want to do my classify on. It's going to be, first of all, the vendor. And just for formatting, I'm going to put in a little space. And now I'm going to add in the computed field that is created. And click on OK. So now we're just doing a simple summarization that the classify will do based on two values, the actual vendor, and I'm trying to find out, based on each vendor, where are there any variances on the format of their invoice number. And here you can see there's a number of results here. Let's look at the bottom two. There's vendor 13070, 904 payments, and then the same vendor, there's one example there, one outlier there, where the format is at almost 6 digits. Now the outlier could be more extreme than that, but this, again, a very simple way. You use a computed field with the classify, and you're identifying outliers and invoice numbers. No programming involved, nothing else, just a very simple test that you can do that could identify some potential duplicates there. These are all hyperlinked, by the way, as well, so if you wanted to click on those to look at what the value was, you certainly could go ahead and do that. Now, moving back to the next example, here is another result set. Now, the first example I showed you is doing a test where two invoice numbers were similar in appearance. This test is similar to that in that it expands the matching capabilities, so not just ones that are maybe similar in appearance, that are just within any sort of fuzzy match. I'm not going to run you through this example now, just for time purposes, but I'm just going to quickly highlight for you just what I mean by that. So you recognize this example that we saw in the first test we ran, but there's also some additional results here. Here you can see if I did a fuzzy test, difference of 1,998,068 got matched up with 1,98086. Again, two invoice numbers with just a two-digit, or just the one transposition error at the end. All the other elements of this are exactly the same. And as well, on the bottom two as well, you'll see the same thing. There's going to be either a difference of 1, the first example here, 991,548, and then the next example, 99, there's a 6 in there, 1,548. So I think you get the idea now, based on my explanations and doing this sort of analysis, you can get some good results doing fuzzy on invoice field. Now, let's move on to the next example page now, which I think so here there's the need a lot of times to identify keywords or flag words that may be in a particular data file. And it's a matter of how can that be accomplished in a straightforward, simple way, and also allow you to manage that list in a very simple way as well. So in this particular example here, there is the same payments file we're working with, but there is a description field. And whether that's on a procurement card or any sort of data source that you might have, if you want to look for certain words or sequence of words, see if they exist in a file, that'd be very useful. Now, before I jump in to software, I'm going to switch over here to Notepad on my machine. This is showing you a simple text file that I've named payment flag list.txt. And in this payment flag list is a list of like 50 terms. And I think I grabbed this list off of LinkedIn forum that I saw. Here are 50 terms, obviously looking for strip club or poker or other elements that might indicate about a red flag, a yellow flag on a particular data source. Now, how that can be applied, if I go back over here to Analyzer, I can go to my screen and type in a function there called listFind. And then I can reference the table that I list I want to do. So I go, okay, I want to reference this simple file. I want to go payment flag list. And then I want to apply as a description field. So I'm just going to drag that up here. So now I want to take the list find, check for this list of words, put a close parentheses on there, and go ahead and run that test. So that's as easy as it is. I'm just referencing that file I just showed you with a list of words. In this case, the list is 50 in it. It could have 50,000 if you wanted to. There's no limit on the number of elements in that list or what's in that list. You'll see here it's not just singular words you're looking for either. It can be full words, full phrases. And we're highlighting some of the values in that list. So went through a million records and found approximately 10 places where some of those words from that payment list were existing in this description field, whether they were in the beginning, middle, or the end. So again, managing that list, if I go back to my Notepad again, having this in a central place and be able to add from it, subtract from it, manage it, it's a much simpler way to manage these processes. You're not going in and changing any of the programs, changing anything else. You're having a simple, centralized list of terms that you can reference and add to as need be. Okay, so that's a little bit, some ideas I wanted to share on the payment flag list. Now we're going to change testing areas, and now we're going to spend a little bit of time on doing a vendor test. This particular test here is going to look at vendor master files from 2 different periods of time and highlight for you where the credit limit has changed. You'll see here the third column, the credit limit, and the first column here is the type of change that we want to highlight. A means added, and F means from, T means to. So I switch over to Analyzer, and as part of this example, I'm going to show you how you can set up a new data source from a database very quickly. So I'll close these down for now. So to add a new data source, I'm just going to go to my server. I'm going to choose my server profile. I'm going to choose relational database, and I'm going to next. Now, if you're not sure what cable's looking for, you can do a speed search. I'm going to look for one's called master. So here's a couple of files here. I want to choose both of them so I can define multiple files at the same time. In this case, I'm going to choose 2, but could be 20, 30, 40. There's no limit how many you can define at once. Click on next. And I'm done. So here are those 2 files, DBO vendor master file October and DBO master file from September. Just open those up, show you what's there. Then these are vendor master files from the SQL Server database that I just quickly defined. Now the test I was going to show you utilizes a command called compare. And here it is. It's a matter of opening up the initial data file I want to work with, in this case, vendor master file from October. And now I want to choose and compare that to try that. Okay. Oh, I didn't expect that. Let's go to Plan B. Here we go. I'm not sure why I did that, so I will, for the purpose of time, I'm going to move on to a backup file here. So again, here's the same vendor master file. If I go to that compare command and do vendor master file for September, let's see if I find that here. One second, bear with me here. Getting some unusual results. There's my file. Okay, so I'm going to go back to here, compare. Okay, one second. I need to do a quick check on something. Hold on, bear with me. Okay, I'm going to try that one more time with this file here and go back to here. Okay, all right. I will try this one more time and then I will move on. And I apologize that as you may know when you do live demos, you are vulnerable to these sort of unexpected occurrences. Okay, I'm not seeing that file here. Okay, I apologize for that. There's something about that data source that was a little unexpected. Going back to that screen here just to finish my thought on that particular file, the ability to compare 2 files and have it identify those differences clearly commonly done for 2 different periods of time obviously is a huge time saver. Now, it's important that it actually works, as it didn't happen here. But taking 2 files, whether they have the same structure, as long as the 2 fields in question have the same width, you can run through and do a comparison, and it will highlight for you again what is different between the 2. It's kind of like changing the capture after the fact. Now, let's move on to another example. Hopefully that will proceed a bit more smoothly. Going back to the area of fuzzy analysis, we showed you a little bit of fuzzy on the invoice fields on the previous file. Now, the more challenging area as well with vendor testing or address testing is how do you take addresses and all the different ways that they can be entered in, and do reasonable, accurate, and time-efficient ways of doing fuzzy testing, fuzzy analysis of those, and look for duplicates. Let me show you some ways how you can do that. Now, we referenced this payment flag list based on that list find function that I showed for you. Here is another table that we can reference within the software, and this is what we call a substitution table. Now, this is obviously a little more North American based compared to maybe some of the street extensions that you have there in Mumbai in India. But the idea is here to take street extensions in a particular address file and standardize them so that when you do your comparisons, the street extensions are the same. If you recall that first example I referenced when I was explaining Levenstein difference, one address had the full street extension of street and one had ST. So if you were just to do an address comparison and everything else is the same, they'd already have a difference of 4. So the intention here is to give you a simple way of standardizing street extensions. We also can do the same thing, say, with first names. And here is a list of common female first names and a list of common male first names. The concept is the same. When you want to do fuzzy analysis, you want to standardize the data as much as you can. Clearly, standardizing last names isn't realistic, but at first names, where you can have many variations, that's another thing you can do. And if we have time, I'll show you both examples. Now, in this case, there is my address substitution table. Actually, let me go back to that file one more time. And actually, let me grab this quickly just to save time. Here is a simple command. Now let's switch back over here. Now let's bring up this vendor master file. Here is an address. Now if I go do a right click on that, go to Add Columns, and I'm going to choose an expression. And we have a whole category here called Fuzzy Search that has a bunch of functions in it. Some of those are what we call normalize. You also see below that sort normalize, and I'll speak to that in a few minutes. I won't show it to you today, but I'm just going to put in the, first of all, the field name that we want to normalize. This is vendor address. And there is that substitution table. So that's as simple as it is. I'm taking the command called normalize. If you were just to put in the vendor address field, what this would do is remove all characters that are not letters and numbers and uppercase everything. So that's what it would do on its own. Now the additional parameter here, what we're referencing a substitution table, is now taking all the variations of street extension and standardizing those. So I'll just give this a quick name here called norm address. Click on OK. Now I'll add that here to my screen. So here we can see the original address, and here we can see what it looks like after you've applied this normalization computed field. You can see here Old York Road is now Old York RD. Avenue is AVE. So in this case, we're shortening them, but the key thing is here we're standardizing what is there. So if I was to go ahead and say do a quick duplicates test, let's say I did a quick test here checking on same city and say the original vendor address, you'll see city. Let's call this duplicate check again. 3. All right. Having a bit of Murphy's Law here with some of my testing here. Let's try that one more time. Analyze duplicates. And try that one more time, and then we'll... Okay. Well, I will move on from that example. Let's see if this works any better. Let's try doing a duplicates test now on that normalized field. And if this doesn't work, I'm going to get a little irritated. Okay, let's try that. Okay. Bear with me 1 second. I'll try to resolve something here. Okay. Okay, now we're back. Let's try that one more time. I'm just going to recreate that computed field. Oh, actually, just put it back in. Add that to my view here. And there it is. I'll drag this across. Now what we want to do is try this one more time. Let's do same city, same normalized address. Okay. My apologies. I'm not getting the result set I was expecting, or the performance I was expecting. Looks like I found a little glitch as far as this testing goes. My apologies again that this has happened. You can get the sense here, and again, if we return back to this slide, here is the result of doing an analysis on this. I'll bring my highlighter up here. Here you can see the original address, and here you can see after normalizing those addresses, this one had Boulevard, the abbreviation, and this one here. So here we have duplicate addresses that are highlighted just by normalizing them. Now, I mentioned there's another function called sort normalize that you can use, and this takes all the elements in an address separated by a space and puts them in descending order. Now, you could think, well, that's a very bizarre looking address after you do that. The intention is here, again, is looking for duplicate addresses in different ways. Here, what highlights that is, here is my one address here in Richmond that has the suite number at the end, and the one below it has it at the beginning. Even after normalizing these addresses, you can see they are still quite different in appearance. After sort normalizing and taking all the objects and putting them in descending order, it actually makes them the same. Now at this point we haven't done any sort of fuzzy testing yet. All we've done is normalize the data, and based on the sort normalize function, you have actually found some exact matches. Now the normal next step from this is to then do some of the same fuzzy testing that I showed earlier. I'm looking for close but not exact matches on addresses. And because you've normalized it first, you're now focusing in on your testing based on the real differences and not on the ones that are maybe going to be triggered by your street extension. Again, I apologize for this. I put a new version of the software on my machine today, and I paid the price for that. My apologies. Okay, let's take this drawings out of there and return to my... Okay, so that is normalizing the and doing fuzzy based on a computed field with a substitution table. The one final example I'll show you on this part, actually maybe I won't show you that. I'm just going to quickly explain it to you. I do want to touch on a few more things. We have time for question and answers. All these slides will be available. Here's an example that I mentioned earlier where instead of normalizing addresses, I've normalized first names. And the example here is comparing that to a list of sanctioned vendor contacts. And here I highlighted with one of our triggers here showing you Linda became Belinda, and they became a match that way. So that is one other way of using the normalize function with first names to come up with better matches. And this example here is actually looking for vendors where the phone number is close. And here you can see trying to find the last 2 digits of a phone number where the same city and the phone numbers are close. You can see here 7C's import got matched up with the word 7. That would be a tough one to find with a fuzzy match, but by looking for close phone numbers, that's another one you can look at. Now, I want to spend a little bit of time on deployment and administration. Clearly, you can have people in your organization who are can be tasked with maybe assisting all the other users on their use of analytics, whether that is an audit-specific tool or more of a general tool or even a dashboard. Our software here, you can organize work with different projects. In this case, I'm going to use projects to kind of show you different types of user experiences. So here I have a simple test, call it a script or a procedure, and that I can run. And this allows me to perform a certain query. So I'm just going to show you this. This is going to be a simple dialog box that goes ahead and does an analysis. Now, let's say I ran that test, developed it, and say, okay, this is good to go. I'm happy with how this test works. I can now take that and drag that test into what we call it a shared folder. And I'm going to just make that data available to that as well. So I haven't made any changes, but now just by simply dragging it into a shared folder, it is now going to be available to other users of the software. Now you'll see here there's a menu, and again I'm not going to get into too many technical elements here today, but there's an element here where you can create shared folders. An enterprise shared is going to be a shared environment on a Windows server, and a team share is going to be a shared environment on a network environment. The example here I'm showing you is on an enterprise and a Windows server share. Now I'm going to switch over to a different project here to represent a different user. So let's pretend I'm another user. I have Analyzer, RPGS Analyzer installed. Now if I was to go to that same shared folder, you'll see that test is available to me now because I've created it and developed it in there. So this is as easy as it can be for you to develop tests, put them in a shared environment, and then I can go ahead and run this, just like I did before. Now what I can also do in this situation is schedule this test. So if I want to go ahead and schedule this job to run at a certain time, have it do all those things can easily be done once it's in a shared folder as well. So scheduling a test is there. Now I'm not going to spend too much time on that. The other thing I was going to point out is any script that, as an administrator, you put into a shared folder for your team, that script is immediately exposed to the applications menu. So if you had Analyzer installed there in Mumbai, I could set it up so that just by dragging you get access to the shared folder, and by putting those tests in there, you could immediately go ahead and grab them off the applications menu. It can happen dynamically, and because this is accessing just our Windows server over the internet, the deployment of tests to a broad group of people, whether that's global or just across town, can be as easy as dragging them into a shared folder, and that can be available now to be used and referenced by other users. So that's one thing I just want to touch on as far as deployment and administration of tests to other users of the same technology. Now, if I go back to my previous project, if I had tests that I now wanted to make available to non-Arbutus users, people that were involved in other things, I could easily do that. Let's take an example here. If I go grab that same file here. Here is the inventory test. I'm going to drag this to a different shared folder called non-Arbutus user ones. I've given them some names here so you can intuitively see what's happening. And I have another project here called non-Arbutus users. Again, this is, I'm showing you this to kind of make it clear to you what is happening. So just by dragging it into that shared folder, that when you talk about simplifying deployment of things to a group of users, and those users are not very technical or don't want to necessarily learn a new tool like an Excel, an IDEA, or an Arbutus, you can engage technology now that allows you to have all of the data definition capabilities of a tool like this and all the scripting capabilities and programming capabilities and extend that to a broader group of people who don't necessarily need to know the technology. So in this case, I put a simple inventory file into a enterprise shared folder. Now I'm going to switch over now to Excel as an example here of how this can work. So if I'm an Excel user, I can go here and I'm going to choose something called Legacy Link Non-Users. And what that does, essentially expose everything in that shared folder I just showed you. In this case, there's only one file there. If I take that file, bring it across, click on Next, I've now have access to that shared folder and that data source and can bring it into, in this case, Excel. I'm showing you Excel because everybody knows Excel, but this could be a dashboard. It could be any other tool you might have. That's as easy as it can be as far as supporting the deployment of data or even actual analysis to non-users of audit-specific tools like this. Let me quickly show you another example, and then I think I'll open it up for questions. If I go to my desktop here, you may have saw I ran that test a few minutes ago. If I have a spreadsheet here, I'm going to double click on that spreadsheet. And here you can see the same dialog box that I ran a few minutes ago straight from Analyzer. I'm now actually having that launched right within Excel. And I can choose an option here, go ahead and run that, and it returns our results to my screen. So not only can you extend the data sources, you can actually embed and run actual audit analysis for less technical people and have that be brought in. Again, this is an example with Excel, but this can also be applicable to dashboards and other types of tools that you might have. So let's just want to touch on that, make mention of that. Deployment of tests to both other audit users, deployment of non-audit users, and the creating and deployment of tests. I showed you a little bit of that, of dragging that script into a shared folder and then scheduling that. Those are all things that can be, those are things people want to do. It's a matter of what are the different ideas and concepts out there that allow you to make that much simpler and that you're not going through the time to manage it and run those things out and make it a straightforward process. Now, we're coming up. I wanted to make sure there was time for Q&A. I just want to see how we're doing for questions here. Have there been many questions submitted? I'm not sure. I want to make sure we have time for those. I'm not seeing any questions here. If you had any questions, please maybe type them in to the chat box on your webinar panel. And while you're submitting those, I'll maybe just touch on a couple of other capabilities here, last points here. Setting up and validating data. I showed you earlier an example of defining multiple tables in a database as far as the one way to do that. Now, what is becoming a common practice for organizations is to not only get the data that they've asked for, but to also say, as a validation process, can you please also give the SQL that was used to generate this result set? And you are given that as a sort of an audit check. Now, what you can do is then translate that SQL into the equivalent type of query that you would have in whatever tool you're using. Now, a much simpler way is to actually be able to take that SQL and run that against the data yourself. So if I switch over here to, my notepad, there we go. Now this is a very simple SQL query that I have ready to go. It's simple select statements grabbing a couple of tables, and it's doing a join based on customer ID. Again, I'm not trying to make it too complicated, just trying to show you, I don't know SQL, but if someone gave me the SQL command, the SQL statement, I could take this now, return to Analyzer. So I go here to, oops, go there. I go under the data menu here, you'll see there's an option there to go SQL. And you can run this on local data or on server-based. And I'm just going to quickly choose a server profile, choose SQL Server. And here I can plunk in that SQL. Again, so I'm within the software itself. You are given, say, the SQL that was used to generate a certain data set. You want to validate that what you received is correct. And I am now going to, I should put in my password. Validate that. And now click on OK, run that. So just, I fired that SQL, and again, this is a very simple example here, where I've generated an output here from the SQL Server data, and I would now validate this against the original data source that I was given. So you get a sense here that taking SQL, whether you understand it or not, but be able to just plunk it in and run it can really simplify the validation of the data that you may want to work with. All right, that's another example here. So that's that. Was there any questions that, okay, here we go. Let me go into here. Okay, I'm trying to ask this question. That's okay. Okay, I'm just trying to go through these questions here. My dialog box here is quite small, and bear with me here. So one question is, how is this tool different from ACL? Well, there are a lot of ways to answer that question, and I presume there's probably a number of ACL users out there. Some of the ways that we are sort of attracting ACL users is on some of the fuzzy analysis that we do. But there are, depending on what you're trying to accomplish, if you were to survey 10 different ACL users and why they switched over to us, you're probably going to get 8 different examples, 8 different answers to that. For example, if I go into our help menu here, go to contents and type in ACL, there's a whole list of differences right here on how we are different than ACL. And why we are different, I'm not going to even suggest that we are. It's all a matter of what you're trying to accomplish, and there's a lot of different reasons there. Certainly, as you saw with the scheduling of jobs, once you want to get into a more of an automated environment, you will find that we have essentially give you one interface for just to accomplish that, and that can really make things simple. Apologize. The dialog box here that I'm, oh, here we go. I figured it out now. Okay. Another question here was for the normalized address to work in an Indian context. Yeah. So certainly to have this work with Indian addresses, you would need to create your own normalized address. Now, a good way to do that, even using the software, is to go through, if you're able to get street extensions or even parse that out of an address file, and then you can summarize all the different options, all the different street extensions, and then uppercase those and that's as a starting point. Now, the substitution table that I used today was actually from the U.S. Postal Service. I think one of our customers gave it to us, and then we made some additional changes to it. I'm not sure if the Postal Service in India would have a similar type of table to this, but that would certainly be a good place to start as well. Now, there's a question here, how much time is required to learn the functionality of software? Well, hopefully what you saw today is that there are some things that you can do with very little skills. Now, all these sort of audit-specific tools out there are intended to help an auditor become a better data analyst. And that requires skills beyond just how to use a tool. It requires you to sort of think about the questions you want answered of your data and how you're going to accomplish that. And so partly the training required, if you have a certain aptitude for data analysis, a lot of times you can jump into a technology like this with very, very little training. And depending on what you're trying to accomplish, in the case of some of the fuzzy analysis that I showed you earlier, you want to be able to certainly understand what the analysis is doing, but the time involved to set those up and run those tests are obviously very, very minimal. So we have some people that, if they've used other sort of analysis tools already, will not need any training. They will just obviously use the help, maybe call tech support once or twice, and away they go. If you're a brand new user and aren't really comfortable from a data analysis role, then certainly an introductory course, I would say, would be the more common way to sort of get your feet wet and get some confidence with how to do the analysis. But it's always important just to think of 1 or 2 things that you want to try and start with that. Don't take on too much. Just think of 1 or 2 things you want to take on and go from there. There's another question here about how does it help in many-to-many relations on multi-dimensional data. Well, certainly the ability to do many-to-many analysis, if I was to, I'm just going to quickly pull up a menu here. Under the join command here in the software, you'll see we give you a bit of a Venn diagram showing you what you get. One of the options here is actually a full-on many-to-many. And so all the options are there, and including, obviously in the case of a many-to-many, we allow you to apply expressions to that many-to-many, because creating a many-to-many just create a very large data set. We also allow you to apply conditions. So commonly, I did some fuzzy analysis earlier within the same data source. Where you want to do fuzzy analysis between data sources, this is where, again, we're many-to-many. By applying a fuzzy condition, like a leverage sign near or similar, based on whatever values between the two files, would be an excellent way to utilize the many-to-many capabilities. And if I'm not answering your questions to your satisfaction today, please, would love to hear from you. Have you email me after a session today. Okay, this may answer one or two more questions, and then we'll sort of respect everybody's time and their schedule here. Well, go ahead. Should we wrap things up?
Yes. I think we need to respect the time and also respect the time that you have in the Canada. Dear participant, we are going to share these questions you have asked to Mr. Brad and request him to give a feedback or provide responses. I hope that will help. Mr. Brad, on behalf of IIA Bombay chapter and our sponsor Audit Time, and on the behalf of all the participants, I thank you and express my gratitude that you have taken our request to come here and give us an idea on how we can do a better data analysis by using the technology. We thank you.
You're very welcome. Thank you for inviting me today, and I hope everyone found something useful from the meeting today, and certainly I'd be happy to follow up on all the questions that we got today to make sure that they're answered to your satisfaction. Have a wonderful day, everybody.
Thank you, Mr. Brad.
Bye for now.